everyone, my name is Maisie and I am coming to you live from the Central Caribbean Marine Institute here on Little Cayman. Now we are obviously on lockdown here in the Cayman Islands. Before we get started, I do just want to reiterate what I said last week, with that we are abiding by all of the curfew and government rules in place. Myself and Jack, who is our wonderful producer, are currently living at station, and the two of us in this broadcast are very socially distant. So make sure that you are staying nice and safe at home and you are following all of the government protocols as well. Now, everyone watching, we all know that this is an interactive broadcast. So you should all be watching via YouTube, and just to the right of that video feed, there is going to be a live chat box. Now we want you guys at home to be as involved as possible in this broadcast. So please do send in all of your questions on that live chat so that I can answer as many as I possibly can during this broadcast. We do also have an in-class activity sheet, or an at-home activity sheet, as I suppose it now should be, which we would really like you guys to get involved in, and I'll speak more about that a little bit later. Now, today's broadcast is called Why Do We Need Coral Reefs? And we're going to be going over, first of all, some of the key threats that coral reefs are facing. Then we're going to head underwater once again with Katie, and we're going to go back to our coral nurseries and learn about some of the threats that, they're facing down there. And we're also going to be learning about how to measure our corals as well, before we come back here for a live question and answer session. So it's going to be lots of fun. Now, to start today's class, I'm actually going to recap what we learned last week, just in case you guys at home weren't watching our broadcast. So last week we learned all about what corals are. So corals are made of lots and lots of teeny tiny creatures called coral polyps. And these are kind of like upside down jellyfish with their tentacles floating in the air. Now, these tentacles contain nematocysts, which are those stinging cells, and using their tentacles with these stinging cells in, they are actually feeding from the water, and this is how they get most of their food. But the majority of the food that they get comes from the algae that lives inside of their tissues. Now, this algae undertakes photosynthesis just like all plants do. So they are using light from the sun, they are producing oxygen, and they're producing lots of sugars as well. So this algae that lives inside the tissues of the coral is actually producing lots of food for them, and this is how they survive. So very cool. Now, we also learned about some different types of coral. We know that corals come in lots and lots of different shapes and sizes. And the one coral that we have been focusing on has been the staghorn coral. Now, this coral used to be really, really dominant here in the reefs in the Caribbean, but due to lots of threats, we actually have to be growing it in our coral nursery because the population has significantly decreased. So last week we went down and we visited our coral nursery and we learned all about why we have it down there. So very, very exciting stuff. Let's get started with some of the things that we're going to be talking about today. So let's get started with the threats that some of our coral reefs are facing. And this is the reason why we really need to have our coral nurseries, so that we can try and grow as much coral as possible and put it back out onto those reefs. So when we start talking about some of the threats, the first ones that I'm going to speak about are going to be some really, really big global threats and global concepts that we're going to be talking about. And the first one that I want to talk about is actually global warming. Now, our ocean and our planet has been getting much, much hotter. On average, there has been a 1 degree centigrade rise in the mean overall temperature of our planet. And this has been happening for a very, very long time. So every single decade since the 1960s has actually been getting hotter and hotter and hotter than the last. Now, why is this happening? Well, there are several reasons, and one of the key reasons is that we are burning lots and lots of fossil fuels, such as oil and gas. And this is releasing some gases into the atmosphere, such as carbon dioxide and methane, which are called greenhouse gases. And just like the glass that makes up the greenhouse, these gases actually trap heat around our planet, and that's one of the reasons why it's getting hotter. Some of the other reasons are land use changes and also deforestation as well, because if we're taking up all of those trees and all of those plants, then that means they can't undertake as much photosynthesis. So just like the algae we spoke about just a couple of minutes ago, they are using the sun's energy, they're taking carbon dioxide and they're changing it into oxygen. So if we're actually removing some of the plants that we have here on the planet, then that means we're going to have more greenhouse gases like carbon dioxide, which is going to cause us to get even hotter. So let's think about our planet as a whole. Most of our planet is actually covered by the ocean. So over 70% of our planet is water. So what do we think is absorbing the most amount of heat? Do we think it is the land, or do we think it is the ocean? Well, if you guess the ocean, then you are completely correct. Because there's more of it, it's absorbing much more heat. So they think that actually 93% of the heat that is produced in our atmosphere is absorbed by the ocean. So this means our oceans are actually getting quite hot as well. Now, this can have many implications on the life that lives in the ocean, but one of the key environments that's facing lots of threats because of this is actually coral reefs. So something happens in coral reefs when there is increased temperatures, and one of the key things that happens is actually called coral bleaching. So remember that algae that I spoke about earlier that lives inside the coral's tissues and we just said gives it most of its food? Well, what happens when there's lots of environmental threats, including increased temperatures, is that this algae is actually forced out of the coral. Now, when the coral doesn't have this algae, it means that it doesn't have most of its food source, because the algae actually provides the coral with around 90% of its food. Now, what I didn't mention earlier is that this algae also provides the coral with its color. So when this algae is removed, the coral doesn't just lose its main food source, but it is also losing its color as well, which is why it's called coral bleaching. And increased sea temperatures is one of the key reasons why this coral bleaching is happening. Here in the Cayman Islands, we had a massive bleaching event just last year, and we have several reefs that are behind us right here, and all of those reefs actually bleached. We were seeing coral bleaching all the way down at 60 or 70 feet underwater. So that's about, 15 to 18 meters or so. So really, really deep water. Even there it was bleaching as well. So this is a huge threat that the environment is facing, especially coral reefs. Now, it's not just heat that the ocean absorbs. It is actually different gases that are in our atmosphere as well, which leads us on to our next threat that we're going to talk about, which is ocean acidification. So we spoke about there being lots of carbon dioxide in the atmosphere. We're burning lots of fossil fuels. This means that there's lots more of these greenhouse gases, and these are actually absorbed down into the ocean. And the ocean actually absorbs about the quarter of the carbon dioxide that's in our atmosphere. Now, we're going to get started with a very quick chemistry lesson right now, because what actually happens when this carbon dioxide is absorbed by the ocean is that it reacts with the seawater and it forms something called carbonic acid. Now, I don't know about you guys at home, but when I was in chemistry class, I learned that acids are really, really good at dissolving things. Now, this is not so great for the things that live inside the ocean, just like the corals themselves. Last week, we spoke about the corals being made out of a calcium carbonate skeleton because they're really cool and they actually absorb this calcium carbonate from the seawater itself and build their own skeletons, which is epic. But what happens when there's lots of carbonic acid in the water is that these skeletons actually start to dissolve down, and it's a lot harder for them to grow. Now, one of the activities which is on your activity sheet, which you should all have at home with you, is actually an ocean acidification experiment involving a couple of hard-boiled eggs. Now, I know that most of you, we can't go to the beach and we can't go and pick up any, dead coral skeletons on the beach at all. So let's use what we've got at home instead. Now, an eggshell is actually made out of calcium carbonate as well. So our in-class activity sheet is we are actually going to be putting one egg in some water and one egg in some vinegar. So any sort of household vinegar will do, because this is an acidic solution as well, and this will also dissolve down that calcium carbonate. Now I'm just going to wander over here quickly because I actually did this experiment earlier, and I'm going to put it's very strange, I'm going to put my eggs in front of the camera here. So we can see this egg here. I put this in water, so I hard boiled it first of all, then I put it in water and I left it overnight, and we can see it's a normal egg. It's nice and hard. If I push this, then it's nice and solid, and we can see that is really solid shell over there. I'm sorry, Jack, I just sprayed him with egg behind the camera. Now, if we look at this one here, I put this one in vinegar, and we can see that its shell on the outside has actually started to dissolve. So it hasn't dissolved completely yet. If I put it in vinegar for any longer, then the shell would completely dissolve away. But we can see that it's really weird and squishy. So there's not a proper solid shell like we saw with the last one. It's just all kind of gooey like this. So this is definitely an experiment which you guys can do at home. So you should definitely go and try that and send me in some pictures for our next broadcast. So that is one of the key threats that is facing the ocean. What we're going to do now is we're actually going to move on to some of our next ones, that I know that time is already going very quickly throughout this broadcast. So the next threat that I want to touch on quickly is actually going to be overfishing. So when we are going out onto the reef, we have to remember that the coral reef is an ecosystem as a whole, and everything is really interconnected in these big food webs, and everything works together. Now, if we are going out onto the reef and we're taking lots of fish and maybe some invertebrates as well, then this is going to have a significant impact on the health of the coral, especially if we're removing those really important herbivores being creatures that eat plant materials. Then this is actually going to cause a huge increase in the amount of algae that is on the reef. Now, we spoke last week about why we have to clean our coral nursery frames so much, because the algae likes growing over the top of the coral, and it can cause it to grow much slower and cause its health to reduce. So if we're taking out lots of fish out of the ocean, especially some of those herbivores, then what's going to happen? There's going to be more algal growth on the reef, and this isn't going to be very good for the coral at all. Now, there is also another threat which is a lot more closely linked to humans than some of these global ones that we've been speaking about. So we are going to be speaking about some coastal development. Now, we can go out on our reefs, we can fish. Also, there's lots of coastal development and there's lots of pollution as well. So if we're thinking about the communities that are living in this coastal environment, what happens if there's lots and lots of tourists? Potentially we're going out onto the reef, we're accidentally damaging it, we could be taking some of the fish, we could be leaving some plastic pollution or something like that behind as well. So these are lots of threats that we are facing on some of the local coral reefs here in the Caribbean. So this is definitely something which is a huge threat to some of the coral reefs, definitely here in the Cayman Islands as well. So we've just spoken about quite a lot of threats to coral reefs. We've spoken about global warming, how that is causing an increase in the water temperature, and this can cause coral bleaching. We've spoken about ocean acidification, how the removal of certain fish species and invertebrate species can cause there to be lots of algal overgrowth on coral reefs, which can be a huge threat to them as well. And how sometimes when there's lots of coastal development and there's lots of people that are in the water, this can actually cause some damage to the corals as well. And it means that there may be more plastic pollution, sewage pollution and stuff like that. Now, all of these threats combined make our last threat a lot more likely, and that is actually coral disease. So I want everyone to think about when sometimes they feel a little bit sick, then maybe they're a little bit stressed, they're going to be more likely to get sick as well. So if you think about a coral reef and it's got all these stressors that are on top of it, then it's going to be more likely to get sick and it's going to be more likely to get a disease. Now, there are lots of diseases that we do find on corals, and this is one of the key threats that we're facing in many, many areas of the world. So coral diseases, we really don't know very much about them, but we are trying to learn about them as much as we possibly can. Okay guys, we have gone over several of the key threats. What we're going to do now is we are going to shortly go underwater, because the reason that we have these coral nurseries is we really want to help prevent some of these threats that are facing coral reefs by taking some of the species of coral and putting them into this nice, safe environment. When a coral is in a coral nursery, it does remove some of the threats that I've just spoken about. It's not going to remove necessarily the ocean warming or the ocean acidification, but it is going to prevent there from being lots of algae overgrowth. We are going to prevent the likelihood of them getting a disease. Hopefully they will be able to grow a bit faster as well. There'll be less pollution. So this is one of the reasons why we really do need our coral nurseries, and we really need to make sure that we're keeping our one that's just behind me over here nice and clean, like we learned last week. And also we do need to measure the growth that we're finding in our coral nursery as well. So what I'm going to do now is I'm going to hand you over to Katie, and she is going to teach you about how we measure some of the things in our coral nursery.
Basically, the whole timeline of growing corals is we go out to the reef, we find a healthy natural colony of staghorn coral, we monitor it for about a year. We're looking for things like disease, bleaching, predation, because believe it or not, there are animals that eat corals like fireworms and snails and damselfish as well. And actually, we've got a snail on this coral here. If Drew can come in and see that, there is a little tiny snail that's attached itself to this coral colony and is actually eating the tissue off of that coral. So this is a real predator that eats coral, and if I were to pluck this off, you would see that there is a area of empty tissue left behind, and this is the snail that was eating it. So we need to monitor for things like that. So after we find this natural colony of coral out on the reef, we need to monitor it, as I said, for about 1 year. After 1 year, if we determine that that coral doesn't have any signs of bleaching or disease or predation like we just saw, then we can go ahead and assume that it is 100% healthy. We'll take some clippings from it, just like you might take some clippings in your garden at home to make new plants, and we'll bring them into our nursery like you can see here. Now these have been here for a while, so they've grown out quite a bit. And once they've grown to a certain size, we either decide to take clippings again and rehang smaller pieces into the nursery, or we'll choose to outplant them directly onto the reef. But before we want to outplant them, we want to see exactly how big they are when we put them on the reef, so that we can continue to monitor them over time. The unit of measure that we use for these corals is called total linear extension, or TLE. And what that is the measurement of each branch in centimeters added up all together. So first, we'll start with the main branch of this coral here. So from tip to tip on one branch, I've got about 14 centimeters. So you want to make sure to write that on your data sheet. And then the next branch, from the base of it to the tip, is about 15 centimeters. And then the next branch is about 15 plus 3, so about 18 centimeters. And then this branch here is about 8 centimeters. So we did the main branch, the second, third, and fourth. We'll do the fifth one. It's about 15 centimeters. And then the last two branches are smaller. We've got about 5. And let's see here. And 3. Go ahead and add up all of those lengths of each branch and see what you students get all together. And I got about 83 centimeters of total linear extension all together in that coral after I added all of those branches up. Alright, so that's pretty much the first step after you've cleaned the corals and you measure them before you go ahead and start outplanting each colony.
That was a fantastic demonstration by Katie on how to measure the corals in our coral nursery. Now, for everyone watching, you can actually do this at home because on your in-class or at-home activity sheet, you actually have an activity where you can measure the corals yourself. Now, I know that you don't have a real coral skeleton in front of you like I do, but you do have a cutout and you can use your ruler to measure all of the different branches and see how big you think that coral is and give the correct total linear extension of that coral. So we actually are having a couple of really great questions that are coming through already. Please do keep sending through those questions. What I'm going to do now is I'm going to quickly go over how we can combat some of those threats to coral reefs, especially for you guys at home that don't live right next to the wonderful coral reef environment that we have right behind me. So get those questions coming in, and in a couple of minutes time I will start answering them for you all. So I know that most of our viewers unfortunately don't live right on the beach, and even now for those of us that do live here, we are actually under curfew and we're not allowed to go in the water at the moment. But that's not to say that we can't all be helping coral reefs. Now, here are some really great suggestions of what you can do to help save coral reefs and just the wider environment as well. So the first one that you can do is you can reduce your waste. You can reduce, reuse, refuse, recycle, and you can reduce down your plastic consumption, for example. Now, plastic pollution is a huge global problem, and if it gets to the coral reefs behind me, then that can have a really, really negative impact. So by trying to be more environmentally friendly and reducing down our plastic consumption, then we're going to be having a positive impact on coral reefs. Now, another one, sorry guys, I've just been interrupted of photo bombs by the police helicopter. So let's continue with what we were talking about. So how else can we help coral reefs? Well, we can purchase environmentally friendly products that we know are not going to be harming the environment. So, for example, if we are going to be eating, fish, for example, that maybe potentially rely on coral reefs for part of their life, then let's make sure that we're buying really environmentally friendly, for example, fish products, because that's going to be helping the overall reef health. Now, another way that we can help is by trying to reduce down our carbon footprint. Now, we spoke about some of those bigger kind of threats with the global warming and the ocean acidification that is caused by a lot of these fossil fuels burning and the greenhouse gases going into the environment. So by trying to reduce down our carbon footprint, so for example, by turning off the light when we're not in the room, turning off our AC units when we're not in the room as well, maybe cycling rather than getting in a car. These are all things that are going to really help the overall planet, and through that be also helping coral reefs as well. Now, another thing that we can do is we can try and support lots of environmental organizations. So there are lots of great organizations in the world that are doing some really, really great things to help not just the coral reefs, but the environment. Now, there are a couple that are really great here on the Cayman Islands. We have the Guy Harvey Ocean Foundation. They're doing a really great job. The National Trust, the Department of Environment, Magnificent Mangroves on Cayman Brac. There are lots and lots of different organizations that are really trying to help. So we support them as much as we possibly can, not just in our community, but in the global community as well. Then that's going to be really great. And also, I spoke about this last week, we need to expand and share our knowledge. So if you learn anything in this broadcast, then I want you to go and tell your friends. So send them a message and let them know that you learned something really cool and you learned something about the environment, and that we need to all try and work together to protect it, because it's only together that we're all going to have a really positive environmental impact and help reduce down some of these threats that coral reefs are facing. Okay guys, I have some great questions that are coming in and I'm going to start answering them, but there's definitely a few more that need to be sent in, so do keep sending in those questions and I'll try to get to them all before the end of this broadcast. So the first question that I'm going to answer is coming in from Ali, and Ali is asking, how many coral nurseries do we have here on Little Cayman? That's a fantastic question, Ali. We actually used to have a few more coral nurseries than we have now, but at the moment we have one key coral nursery, and that is the one that is right behind me and the one where our video is filmed for today, which is at the Deep Nursery. Now, our Deep Nursery is in around 50 to 60 feet of water or so. So that's around 15 to 18 meters for those of you that are tuning in from the UK, where we definitely don't work in feet. And this is where we're growing the majority of our coral, and it's doing really, really well there. So in the wild, the coral normally grows, as staghorn coral we're talking about, grows about 10 to 20 centimeters a year, whereas in our Deep Nursery, it's actually growing about 70 to 80 centimeters a year. So it's doing really, really well over there. And we were just out there last week doing some cleaning on it, just like Katie was doing in last week's video as well. Okay, we have some more questions that are coming in. So we've got a question from Tess. So Tess is saying, are the snails bad for the corals? Are they predators? So excellent question, Tess. I think that was kind of answered in the video, but I'm going to go over it again anyway. So there are lots of creatures that do eat coral. Now, these are part of the natural ecosystem, just like there are some caterpillars, for example, that eat trees. There are creatures that eat corals as well. So this does include some snails that eat the coral, and there are also fireworms, for example, that eat the coral as well. Yes, they are predating on it. Yes, they are unfortunately damaging it, but they are part of the natural environment. So as long as the population of these predators is relatively low, then it does mean that it's still a normal part of the ecosystem, a normal part of the environment. And in most cases, these predators are, sometimes preying on the corals that aren't as healthy. They're a little bit sick already. So they're kind of removing some of the ones which, aren't in the best health. But great question, Tess. Thank you so much for asking that. Okay, we have another question that's coming in from Jenna, who's saying, how do you know if a product is environmentally friendly? Well, that is an amazing question, Jenna, and I think that's a really important one for everyone to know. Now, there are lots of different stamps that I'm going to call them stamps, that you will find on some products. So, for example, you may have the like the Rainforest Alliance. There'll be a stamp on there. You have sustainable fishing stamps that you'll find on food as well. So, the key thing is just reading the product that you have, and you can do a little bit of research as well, for example, on the products that you're buying. But most things are very clear when they are environmentally friendly. Now, another thing that you can do to have a more environmentally friendly product is to try and just use or buy products that have less plastic on them. So, for example, a great one and a switch that I have made recently is I'm not using normal shampoos and conditioners anymore that come in big plastic bottles. Instead, I'm using barred shampoos and conditioners because they have less plastic on them and they're all made of natural products. So that's a great environmental switch that perhaps you could do as well. Okay, I have a question coming in now from Kira, who's asking how many types of coral are in the nursery? That's a wonderful question, Kira. The main coral that we have in our coral nursery is this staghorn coral right here, and that's the one that you were seeing in our video as well, where Katie was cleaning and measuring the corals in the coral nursery. But we do have another couple of types in there as well. We have the very closely related Elkhorn coral. So this one's called staghorn coral. Let's say it's kind of its cousin is called the Elkhorn coral, which is also really endangered as well. And we're trying to grow that in our coral nursery, but it's actually quite difficult to grow the Elkhorn coral because it's not got the same branching structure as this guy here. And we also do have one more different species of coral as well, the Orbicellas, and we are trying to see if we can grow those as well, but they are more bouldering corals. And when we spoke last week, we said that they grow really, really slowly. So these guys are growing, said 10 to 20 centimeters a year in the wild, and those bouldering corals are growing probably about ½ centimeter a year. So it is taking a lot longer to try and grow them. So we only have a couple of teeny tiny little pieces. The main focus is on this staghorn coral right here. Okay, we have a question coming in now. Oh, another question from Jenna, who is asking, is coronavirus impacting coral reefs? Now, this is a really interesting question, Jenna. Specifically here in the Cayman Islands, it has impacted coral reefs in a relatively positive way. The main reason being is that there are essentially less people in the water. We are not allowed to go out for water sports. There's no diving on the coral reefs. So there's less human impact, because sometimes when tourists or locals or just people that are just diving in general, maybe they'll accidentally touch a coral and they'll break it and they can cause damage to it. So the fact that there are less people in the water does mean that the corals are probably having a little bit of a break from their time with humans. Also, because there's less boats in the water, it may potentially be that there's less engine noise, which could actually increase the amount of fish that are on the reef. Now, we haven't done any studies looking at that specifically here, because we are not going in the water at the moment, but it would be really interesting to study, and hopefully this is something that CCMI will be able to look at in the future. So we have another question that's coming in that's saying, why did you choose the staghorn coral to go in the coral nursery? That's a fantastic question, and that's from TC Motu. And the central reason why we chose to have this coral in our coral nursery is because it used to be so dominant on the reefs in the Caribbean. So this staghorn coral used to take up a lot of space on the reef. In some areas, the coral reef was about 80% this coral right here. However, what happened in the early 80s is that there was a disease that swept through, and this actually killed the majority of this species. Now, because this species has now died, it has left these huge kind of patches on the reef, and it means that there is less coral cover overall. So the reason that we're growing it in our coral nursery is that it used to be dominant, the population has decreased, and we really want to put some of this coral back onto the reef because it's really fast growing as well. So it's a lot easier to grow fast growing coral rather than slow growing coral, because we get results a lot quicker rather than having to wait many years to grow a coral that's maybe this size or so. It's a bouldering coral. You can see the growth in these guys. As you can see, we measure it lots and lots in our coral nursery by doing those total linear extensions. Okay, we've got a question that's coming in from Cara, and is climate change affecting Cayman? That's a great question, Cara, and yes, it is. Climate change is impacting every single environment on our planet. There's not certain areas that are, not feeling it, essentially. So yes, we are having much warmer waters around our island. I spoke briefly earlier about there being a really big bleaching event that happened last year, and this is just one of many that we have been experiencing here. The waters are getting warmer, and this is causing more coral bleaching, and this does mean that unfortunately the reefs in the Caribbean are being impacted and their health is deteriorating because of some of these threats. Now, I've got a question that's just come in now from Ava saying, is climate change going to stop? Well, I think that all depends on you guys that are watching at home. So I spoke about some of the ways that we can help coral reefs. And one of those key ways is by trying to reduce down the impact of climate change as much as possible, by trying to lead the most environmentally friendly life that we can. It may be possible for us to reverse and sometimes maybe even halt the impact of climate change, but that's going to take a huge shift in how we live our lives. And we really do need to be focusing on those renewable energy sources, trying to travel less, eating sustainably, and just being a more sustainable race. So potentially we will be able to stop and halt climate change, but it is going to take all of us to do that. So I want everyone that is watching this to try and be as environmentally friendly as we possibly can be, and then hopefully it will halt a little. So we have a great question that's coming in from Ali, who's asking, how do corals get their name? So fantastic question, Ali. Corals get their names just like all creatures do. There is actually Latin names for every single creature, and this is how we put them into different categories and kind of organize them. It's called taxonomy. So every single coral has two Latin names, its genus and its species. So this is called Acropora cervicornis. Very, very long name. But we do also have common names as well, which make them easier to identify because, for example, trying to say Acropora cervicornis is very, very long, and it's also quite hard to remember that name as well, whereas staghorn coral is nice and easy to remember. And the way that corals get these common names is just generally by people looking at them and deciding what they think they look like. For example, this coral here looks like stag's horns. So that's the reason why it got its name, and it makes it a lot easier to identify. So we have a question that's coming in now of, are there any other coral predators? That is a great question, and we did speak a little bit about this earlier. So the main coral predators that we do find, snails, the fireworms, for example, they are key coral predators. But we do find some different ones as well. For example, there are some parrotfish that actually do bite into coral as well. So there are some fish that eat coral. There are also, for example, sponges that will bore into coral and make lots of holes inside of them so they can live there. The same as some of the boring worms as well. They can actually bury into the coral so they can form their house there. So Yes, there are some other coral predators as well, aside from the snail that we saw in that video. But as I said before, they are part of the natural environment. And as long as their population levels are nice and stable and they're not getting too high, then they're a natural part of the ecosystem, just like all predators are a natural part of the ecosystem. So they're not an issue until their populations get a little bit too high. So your question is coming in from Tamara, who's asking, how do corals get their different colours? Oh, that's a great question, Tamara. Corals, as I said earlier, get their colour from the algae, the zooxanthellae that lives inside of their tissues. Now, this gives them their colours, and different zooxanthellae and different corals react differently to have different colors. So for example, the zooxanthellae in one coral can then be transferred to another coral and it will be a completely different color. So they react differently with each other. But the key colors that you're going to be finding down there on the coral reefs are going to be yellows and browns. You may see some purpley colors as well. You're not really going to see a green coral, for example, but we do see lots of coral colors underwater, and these are always caused by the zooxanthellae, the algae that's inside of their tissues. Okay, so we have another question that's coming in now. So can corals recover from bleaching and disease? So yes, they can recover from bleaching and disease. So let's speak about bleaching first of all. How a coral recovers from bleaching is that essentially that environmental stressor, the one which is causing the bleaching, has to go away. So in most cases, as I said before, it's actually increased temperature which is causing the corals to bleach, and that is the environmental stressor. But it can be that there are too many nutrients in the water, there is too much sunlight, so there's lots of different things that can cause it. But essentially, this environmental stressor has to go away. So if it's increased temperature, then the temperature has to decrease. And then hopefully what will happen is that coral, can actually regain the zooxanthellae, can regain the algae from the water. And then because it has the algae back inside of its tissues again, one, it gets its color back, and two, that means that it's got its key food source back and it can survive. But for example, if this environmental stress is around for too long a period of time, or it's too intense, then unfortunately that coral is going to die and it's not going to be able to survive. Now with coral diseases, as I said, are quite confusing things. They are a combination of sometimes bacteria, virus, funguses, and environmental stresses as well, such as increased temperature, pollution, etc. So yes, corals can sometimes recover from disease, but we don't really know very much about the mechanisms behind that. Last year, we did actually get a huge coral disease outbreak of white band disease in our coral nursery that's right behind us. And a lot of our corals unfortunately died, but what we're seeing now is that some of the corals are recovering and are growing over that disease section. So we're continuing to study this to look at how our corals have actually recovered from the disease. So we have another question that is coming in that is asking, is cold water good for coral? And that's coming in from Jenna. Jenna, you're sending in some really great questions. Thank you so much for taking part in this broadcast. Just like with really hot water, really cold water is actually bad for corals as well. So corals live in this very, very, very narrow temperature range. They're very fussy, in fact. They can only live well within about a 4 or 5 degrees centigrade temperature range. So if the water gets too cold, then just like when the water gets too hot, that can actually damage their health as well. So no, not necessarily cold water is not necessarily good for coral reefs, but if it has been bleaching and there's been elevated temperatures, then bringing it back down to a normal level is really good, and it is going to help the corals. Okay, we've got another question that's coming in from Tamara. So, will reduced coral cover lead to more corrosion or erosion? So, fantastic question, Tamara. If there is reduced coral cover, then what is going to happen eventually is that there is going to be less kind of complexity on the reef. Let's think about this coral that we have right here. If this coral has died on the reef, then what's going to happen over time is this is going to completely erode and it's going to break down. So there's not going to be all of these branches that are sticking up in the water. Now let's think about, for example, if a wave is coming in from out at sea. And if we look behind me, we can actually see some waves that are breaking on our coral reef right here. If this coral is no longer here, then what's going to happen is that wave is going to be able to come straight into the shore and it's going to have a lot more energy. And if it's got more energy, it means that it can erode and take away, for example, more sand on the beach. Whereas if this coral was in the water and the wave hit into it, then that's going to reduce down some of the energy that is in that wave. And it's going to mean that the wave, when it gets to the shoreline, isn't going to have as much energy, so it can't take away as much of the sand, which would be on the beach. So if we look right here, we have quite a nice beach behind us right here, and that's because we have this barrier reef right behind us here, protecting us from all that wave action. So yes, if there is reduced coral cover, then eventually those skeletons of the coral will break down, and then that will cause there to be more erosion from the shoreline. So that was a fantastic question. Thank you so much, Tamara. Okay, a question is coming in now from Cara, who's asking, why are coral polyps only active at night? Oh, Cara, I think you know a little bit about coral biology. That is a great question. And the reason why the coral polyps are only active at night is because during the day, the corals are getting their food from the zooxanthellae that are inside of their tissues. So the zooxanthellae, the algae, as I said before, is undertaking that photosynthesis. So they're using the sunlight and they are converting carbon dioxide to oxygen, and they are producing lots of sugars, which is food for the coral. At night, that is not happening. So what they do instead is they extend the polyps out, and that is when they're undertaking that feeding. So they're doing lots and lots of feeding in the water column. They're eating things like zooplankton, and they're using those nematocysts to kind of sting that prey and feed it into their central mouths. Now, another really important thing to remember is that there are a lot more zooplankton and things that they can eat actually in the water at night. So that is one of the key reasons why they're feeding at night as well. So fantastic question, Cara. Okay, we've got a question coming in from Jennifer, who's saying, do sea turtles eat coral? Now, for those of you that have been on one of my courses here, you will all know that sea turtles are my most favorite creature in the whole entire world. So I'm loving that Jennifer has sent in a question about sea turtles. Sea turtles typically, no, do not eat coral. However, Jennifer, you may have seen that there have been some hawksbill turtles which appear to be eating around the corals. And that's because lots of hawksbill turtles really like eating sponges. And sometimes the sponges, as I said earlier, actually bore inside of the coral itself. So the hawksbill turtles are coming along and they're biting that sponge away, but sometimes they're also knocking the coral off as well. Sometimes the creatures will accidentally break coral as well. We put out some coral on the reef, I think it was a couple of months ago, and we went to go and study it, and it was obvious that a big turtle had just come and sat on top of the coral and had snapped all of the branches. So turtles are causing chaos underwater, but no, they typically do not eat coral. It's only really the hawksbill turtles that will sometimes eat the sponges that are living inside of the coral, which is why they can sometimes accidentally break it. Okay, so we have a question that's coming now from Ava, who's asking, how fast does coral grow? Great question, Ava. Coral grows depending on what its life form is. So a branching coral like this, So the staghorn coral grows about 10 to 20 centimeters a year. If we're thinking about the bouldering corals that look like big rock balls underwater, they're not going to be growing as fast. So they're probably only going to be growing about half a centimeter to a centimeter a year, if that. But most corals will grow so much slower than your hair grows. So they're really, really slow growing, which is one of the reasons that we really need to try and protect them. Because if they're so slow growing, then if they're damaged, it's going to take a really long time for them to actually be able to repair themselves and become healthy once again. Hey, we've got a question that's coming in. I am hoping that I'm helping the ocean by recycling, and that's come in, I think, from Kira. Yes, you are helping the ocean by recycling. The reason that you're helping is that you're actually preventing plastic pollution and lots of other types of pollution ends up inside of the ocean. And we know that plastic pollution is really, really bad. If we think about a coral and then a bit of plastic gets wrapped around it accidentally, then that coral's not going to be very healthy. It's going to get very sick and it may unfortunately die. So yes, you are helping coral reefs by recycling all of your things at home. So definitely keep it up. You're doing an awesome job. Okay, we've got a question coming in now from Jenna, who's asking, why is the Great Barrier Reef called the Great Barrier Reef? That is a fantastic question, Jenna. And the Great Barrier Reef is called the Great Barrier Reef because essentially it is a huge, giant barrier. So we have a much smaller example here right behind me. As I said earlier, we can see the waves breaking behind me here, and this is a barrier reef, which means that we have the land, some ocean, and then we have a barrier of coral that is kind of on the outside of this land area. So the Great Barrier Reef is the exact same, but on a much larger scale. It's forming a huge barrier that runs down all the way on the north side of the east coast of Australia. And it is so big, you can see it from space. That is super cool. So that's the reason why it's called the Great Barrier Reef, because it's huge and because it is a barrier reef. Okay, we've got a question that's coming in now from Emma, who's saying, are you collecting any data about the density of coral when it gets diseased? For example, hanging versus stationary. We, at the moment, we actually were studying the disease in our coral nursery when all of the corals were nice and hung up in the same configuration. It's actually quite hard to try and study coral disease in the wild, but in our coral nursery, it actually provided a really, really great experimental setup for us to be able to study it. So we're not necessarily looking at the density of the coral because most of our coral frames have the same amount of coral that's hanging on them. But what we did manage to study when that coral disease came through our coral nursery is we actually got to look at how the effect of different genotypes of coral impacted the spread of coral disease. So for some of our frames in the coral nursery, just like the one that you saw Katie cleaning and measuring, they are all one genotype. So they are all clones of one another, essentially. It'd be like having lots of identical clones that are all hanging nice and closely together. We also have some coral frames that have lots of different genotypes. So we've got lots of very different individuals hanging next to each other. And what we actually found is that in our coral nursery, when there was mixed genotypes, so there's lots of different genotypes all hanging together on one frame, we found that there was essentially a better recovery from the coral disease and there was less death and mortality of the coral compared to the ones where they were all clones and they were all next to each other. So that was a really interesting study that we did, but at the moment we're not quite looking at the density on how it impacts coral disease. But we are looking at how things are in our coral nursery, how they are grown and how it does affect the actual density of the coral itself, which is very cool. So we do have some corals in our coral nursery that are being hung, like you saw in the video. And we do have some corals that are being held in holders like this. And actually that is affecting the density of the coral itself and how it grows. So not quite disease related, but if you grow corals and they are hanging down, then they're going to be longer and thinner and they're going to be less dense. Whereas if they're stationary, they're going to be much shorter and stubbier and they're going to be more dense. They have a denser skeletons, which is very, very cool. And this has been research that has been undertaken by Dr. Anya Brown at the University of Florida. And there is actually a fantastic presentation, so a reef lecture series that she did for us, which is actually viewable on our YouTube channel. So if you want to know more about her studies, then we will actually link that presentation in the chat box and you can learn about all the excellent research that she has done here. Okay, we've got a question that's coming in from Hax now, who's asking, why do turtles eat algae? I'm loving all these turtle questions. Thank you for sending them in. Some turtles do eat algae, and they also eat lots of seagrass as well. And the key species that does this is the green sea turtle. So the green sea turtles are the only type of sea turtle that are actually like the vegetarians of the sea turtle world. So they tend to eat lots and lots of seagrass, and they'll also eat lots of algae as well. Lots of the other species of turtles do not eat algae at all. So they will focus on different things. For example, the hawksbill turtles really likes those sponges I spoke about earlier. The loggerhead turtle really likes having lots of crustaceans such as conch for their food source. The leatherback sea turtle loves eating jellyfish. So all the different turtles have different things that they eat, and it's mainly the green sea turtles that you'll find eating that algae and the seagrasses. And we actually have lots of them behind us right here because this whole bay is filled with seagrass and algae. So if you look very closely behind me, you may see some sneaking up. Okay, so I think that's kind of it for our questions that we've had coming in right now. We've got one last one that's coming in from Kira saying, how would corals get stronger? That is a very interesting question. And in terms of making corals stronger, there are lots of different ways to define strong and lots of different ways to define healthy. So the corals in our coral nursery, as I kind of mentioned briefly earlier, is made up of lots of different genotypes. So lots of different individuals. They're not all clones of each other. They have different genes and they express these different ways. Some of these genotypes are very good at being bleaching resistant. So they're less likely to bleach when the temperatures are high. Some of them are really good at growing really, really fast. Some of them are very good at reproducing. So this technically makes them stronger corals and better suited at adapting to a very quickly changing environment. What we're trying to do as part of our studies is look at how the strengths of all of these different genotypes, and then this will also impact what genotypes we are outplanting around the island, and seeing, okay, which one is the strongest, which one is the most suited to these different environmental conditions. But ultimately, every single genotype has its strength and has its weaknesses. We're hoping that by growing them in our coral nursery, however, they will be nice and healthy because of the majority of the threats that they would have on the reef are removed. And this means that they are nice and healthy and strong and quick growing, and then we can put them out onto the reef and fingers crossed that they will survive. Okay, we've got a question that's coming in from Emily. So, do sharks hurt coral? Emily, that is a fantastic question. No, sharks do not harm coral. They may accidentally flick a little bit of coral with their tail at some point, but no, sharks are not really interested in coral in the slightest. No sharks will be eating coral for sure. Some sharks, such as the nurse shark, will maybe nestle underneath a ledge of coral and kind of use that as a little home, but they're not going to be causing it any damage. And if we're seeing sharks on our coral reefs, it actually means they're really, really healthy, because sharks are at the top of the food chain. They are apex predators, and only really healthy coral reefs will have these predators. So if we see a shark, one, they're definitely not harming the coral, and two, it's a sign of a really healthy coral reef. So always super cool to see a shark. I love seeing sharks in the water, and I actually saw a great hammerhead the other day, which I'm super stoked about seeing. So that just goes to show that some of the reefs around here are really, really healthy. Okay, I think we have our final question that's come in, and that is, how many coral species are there in the Cayman Islands? Thank you so much for this question. There are quite a lot of species of coral in the Cayman Islands. In the Caribbean, there's around 70 or so species of kind of dominant species that we're seeing here, and ones that I see on most of our dives. I'm going to say that there is at least 25 to 30 really dominant corals that we're seeing here, but we do have many more species than that. It's just that they're not as common for us to see them out on the reef. But we do have lots of diversity here, which is one of the reasons why our coral reefs are so healthy and why they are doing so well. Okay guys, thank you so much for sending in all of your questions. It's been so lovely to be interacting with you today. Don't forget that you do have an activity sheet which you can complete. We have actually had lots of people that have been completing our activity sheet from last week, and we've actually got some really great photos that have been sent through to us. So I think that Jack is just going to put some of those up on the screen now. So we have one that has come in. Let me just find the names here. So 1 second. We have Cal Miller, who is 4 years old, from Grand Cayman, and he has made an amazing coral frame. I'm hoping that Jack is showing you a picture of him right now. I love that he made this coral frame. He's done his own thing using Play-Doh. It looks absolutely great. So thank you so much, Cal, for sending that picture into us. It's so lovely that you're getting so involved. And we also have an awesome coral frame that was made last week by Ali and her mum in Colorado. And Ali is my education intern, and unfortunately she had to leave the Cayman Islands because of the pandemic. But that has not stopped her enthusiasm for coral reefs, and she made this epic coral frame that is like 4 times as big as she is. I mean, she's pretty small, but it's huge. I'm super impressed with what she's made. So I really want to be getting loads and loads of pictures and even videos of you guys undertaking all of these activity sheets that we sent through to you. So we actually sent through 3 activity sheets to you guys this week. We have one where we are measuring corals. We have another one which is our egg experiment, which I demonstrated earlier. And the third one is we are going to be making our own coral colony using some egg boxes. So please do send me in lots of pictures of those. You can either take pictures and comment on the CCMI Facebook page, or you can email them through to us at education@reefresearch.org, and the best ones will be shown on next week's broadcast. So keep yourself nice and entertained when we're unfortunately all having to be stuck at home in order to keep everyone nice and safe. So thank you so much for joining us for this broadcast today. We will be back again next week at the same time. So that is 9:30 in the morning, UTC -5, where we'll be focusing on the importance of corals in their environment and the ecosystem benefits they have. And we're also going to be once again visiting Katie underwater as she teaches us all about coral outplanting. So it's going to be super cool and lots of fun. Thank you so much for joining us. Stay safe and stay at home. We'll see you next week. Bye guys.